Good morning, everyone, and thank you for joining us for the Strategic Open Pit Planning webinar. Before we begin, to ensure that all registrants have successfully logged in and are able to view and hear the presentation, can I ask our attendees to please use the raise hand button on the left side of the screen to verify that you can hear me and see the introductory slide. Okay, we're looking good. If you do happen to have any issues during the presentation, please use the raise hand button and we'll attempt to assist you. Otherwise, you can contact the conferencing support team whose details are featured in your confirmation email from CAE Mining. We'll allocate time after the presentation for a question and answer session, so if you have any questions throughout the presentation, please enter them into the chat box on your screen and we'll do our best to address these during Q&A. Our speaker today is Lee Poulin, who has been a mining consultant with CAE Mining for over 2 years. A graduate of the University of Alberta, he first worked for Teck Coal as a drill and blast engineer and then made his way into mine planning. After a few years of freezing winters in the Rocky Mountains, he uprooted his family and moved to New Zealand. Whilst there, he spent the majority of his time scheduling and optimizing open pit coal for solid energy. In 2011, he joined CAE Mining and made the move to Brisbane. His role here has him working on projects and training for both open pit and underground scheduling and optimization, and he recently completed an open pit coal study for a company in India. Take it away, Lee.
Thank you, Eloise. So just hold on a second. I'm sharing my screen. So yes, yeah. All right, so hopefully you can all see my screen. Just starting up the slideshow. Yeah, so yes, we're talking about Strategic Open Pit Planner today. And first, this is an overview of what we're actually looking at today in our webinar. So first, we're going to look at strategic planning. What is it? We'll go over the strategic workflow that CAE Mining uses in our software. We'll introduce you to the Summit platform, and then go through Strategic Open Pit Planner and what it currently has. Then we'll do a live demo showing the software and answer any of your questions. So first, what is the strategic plan? So the strategic plan is the combination of the geology, the economics, and the engineering. So the geology, I'm counting that mainly, it starts off as your block model. It's the spatial data of the deposit. And the block model will have grade, structure, chemical composition, really anything that in the ground that would affect the value of your deposit that you'd use to calculate the value of your deposit. Then we come to the economics. So all these will be used to build up the value of each block. So you have your different costs, discount rates, the revenue, and different adjustment factors like recovery or cost adjustment, which can also be built into the block model. And then we add the engineering constraints, whether it's slope areas, wall angles, lease boundaries, and obstacles that you would need to deal with either as capital cost or as an impediment to mining. And then we need to also look at possible rates and sizes of the mining equipment. At this point, it would be a fairly high level. So once you take all those three things and you use algorithms and math, we should be able to come out with a viable, realistic plan that is optimized and that you'll be able to actually put in use on the ground. So this is the data flow overview, and so this is coming from NPV Scheduler, which is our desktop application, but it will be the same. It'll be the same in SOPP. So here, the first step is that we import our data, bring in our block model, that we've prepared. Then we build up the economic model, which will assign a value to each block. We use our engineering constraints and generate an ultimate pit. With that ultimate pit, we then generate pushbacks or phases of the pit. And once we have pushbacks that we're happy with, we're able to use the scheduler. And then there's also mine flow optimization, material allocation, and haulage optimization. So this is just looking a bit more in detail at the importing the data. So the data is coming through, we're setting up the attributes or mapping the attributes from the block model. That block model can also have rock types and slope regions coded into it. And as you bring it in, once it's successfully imported, you can check the reports and see that everything looks as expected. So we're able to bring in models from many different packages. Definitely we take our data mine models, subcelled and I guess not subcelled models. The next step is the economic modeling, and here we're calculating the value of the block. So you have a block, you calculate how much it costs to mine it, process it, and then you also calculate what revenue is associated with that. And the system then has multiple ways of determining whether that block is ore or waste. And once each of those blocks has a value, you can move on to your optimization. So here we have, to create an ultimate pit, we use the Lurch-Grossman algorithm. It's fairly industry standard, common. So it will generate an ultimate pit at the end cutoffs that you specified. Once you have the ultimate pit, we're also able to generate the nested Lurch-Grossman phases. So these will be set up as either based on price, profit, or mining cost. So if you were to set it up as price, if you had a $100 assumed cost or assumed price of the commodity that you're selling per unit, then the pit 60 would be at 60% of that cost. So yes, pit 1 will be the smallest, pit 100 will be the ultimate pit that you've run. Another thing that we can do during our open pit optimization is bring in the constraints as far as spatial constraints. We're able to import outlines, and those outlines can either be exclusive, as in they will not be mined, they might be outside of the edge of the mining boundary, or they can be inclusive, that what's in this area needs to be considered. Or we're also able to put in obstacles that actually have prices associated with them. So an example would be if there's a river running through the middle of the deposit, you can factor in the cost of relocating the river or diverting the river, and that can be a capital cost associated, and the optimization will consider that. So here's just an example, and it shows that on pit 5 is the first pit that actually encroaches upon the areas that have costs associated with them. So, all right. The next step that we have, once we actually have our optimal Lurch-Grossman pit and also the Lurch-Grossman phases, our software does something called the optimal extraction sequence. And the optimal extraction sequence actually numbers all the blocks in the model in terms of where they would best influence or increase the net present value. So even though sometimes we're reporting things on a yearly basis, the blocks are actually coming out in an optimized way to increase the net present value, whether you're calculating yearly, quarterly, by month. And the graph that we have here just does show that when you do your ultimate pit, you actually, unless it's a small pit, you won't be able to mine it in quite that manner. So we actually need to bring in pushbacks in a schedule to bring the value, well, it will drop the value, but it will bring it into something that's achievable. So the next step in the process would be generating the pushbacks. So yes, our system is not using the Lurch-Grossman phases as pushbacks, but it's using the Ultimate Pit OES, and you're able to specify what size of pushbacks you're searching for in terms of tons or ore mined, and then it will search and find blocks that are close together and build that up into a shape that fits the parameters that you've given. You're also able to control it in other ways by giving it outlines or giving it different, you can actually have it bring in surfaces to control your pushbacks. The next step, once we have our pushbacks, we're able to generate a schedule. So our software uses, the software uses, I think it's a dynamic programming model. So the schedule, the model will actually get broken up by pushback and by bench into mining blocks, and then those mining blocks will actually be run through the simulation trying to hit different targets, and it will actually, so it's actually forward-looking and backward-looking, so it will seek an optimization that not only optimizes each period by itself, but over the whole frame of the mine life. Right. Then, in the end, once we have a schedule, we can run extra optimizations like mine flow optimization, which can bring up your NPV by wasting low-grade material and bringing high-grade material to the forefront. Material allocation optimization, which allows for, rather than optimizing based on NPV, it's able to optimize based on delivering a consistent product or series of products. So that's using blending, and a good example would be an iron ore mine where you need to consistently ship a certain quality of ore. We are also able to do haulage optimization, and that will estimate the truck hours needed and will actually reschedule the mine to have a more consistent demand on trucking. All right, now we're introducing CAE Summit. So the Summit platform is a cloud-based platform, and to start things off, we're not bringing all of our software currently onto the Summit platform. Right now we're targeting a couple of things that can really use the power of the cloud. So we're targeting strategic open pit planning, underground reserve optimization, also resource estimation and reporting. So the open pit strategic planning is the SOPP, and that's coming from NPV Scheduler, and the underground optimization is the next version of MSO, or Mineable Shape Optimizer. So this is just showing what Summit will look like to people. So the user interface is a web browser, so you'll actually be able to access it from anywhere. So you log into the web browser, you set up your project, and then the data gets processed. We're using the Microsoft Cloud, and they have data centers all over the world. And then once they process, then you'll be able to get your results back. And yes, at this point, I think we have the power to draw on up to 1,000 processors at a time, so a bit more powerful than your desktop. So, all right, bringing in strategic open pit planning. So we'll use the cloud specifically for strategic analysis. What's already on the software is we were able to bring in the economic models. We're able to bring in the block model, generate an economic model, and generate ultimate pits. And further from that, with the ultimate pits, we're able to perform sensitivity to find out the main economic drivers. And we'll also be able to run simulations, which we can use different distributions and find out really what we can expect given the uncertainty of things that we know. And the big thing is that we'll be able to run, or that we are able to run these projects in a matter of hours or days rather than weeks or months. And that when we know these things, we'll be able to plan better, be more proactive in our scheduling, and not have things sneak up and surprise us. So sensitivity and simulation analysis have been possible previous to this. We are pioneering in putting it in the cloud, but really I don't think that we were able to do it to this level of detail previously in any reasonable time frame. It was just too hard. There was the matter of setting up multiple cases and without making any mistakes. And also, in the end, once you've run all the cases, you'd have to combine the data together and get the data for comparison. So the cloud allows us to have all those things taken care of. It makes it a lot easier for us. And also, because it's on the cloud, we can access it from anywhere and share it with the rest of our team, wherever they might be. So what are the drivers for doing this type of optimization? First of all, there's the cost-based ones. We don't know where the world is a volatile place. We don't know where our costs will be 2, 3, 5 years, 10 years from now. So we're able to both use sensitivity and simulation to find out what effects those might have on the future of our mine plan. Other things to look at is the processing options. What happens if we don't get the recovery that we expect? If our plants, there's multiple examples. If the plant doesn't get the recovery, then what do you need to do? And using a system like this, you'd be able to plan for that possibility. So what type of results have we seen with this? We have had a case study where what would have taken 2 weeks' work went down to 6 hours. So that's a 90% time savings. And we can expect that that would be the norm, or even we'd expect even greater time savings. All right. So on the other side of this slide, we're seeing the development sequence. So we've already done, so SOPP already currently does sensitivity and simulation and risk. And the pushbacks and material movement scheduling part of SOPP, which is already an NPV scheduler, will be coming out in 2014. So here's an example just showing how you would do a sensitivity analysis. So in this case, we've brought in a project. It has multiple inputs, and we're checking the sensitivity to 4 of the inputs. So if you're to test you've got your base case and you're going to test the mining cost, well, you'll run an extra 8 cases for the mining cost. And then you'll go back to the base case and you'll start varying the metal price. So in a situation like this, you'd actually have 33 runs to test all these sensitivities. And if each run takes 2 hours to run, you're expecting that this will take longer than a week to process. So Summit is a platform to manage that data and make it much faster. So here's an example of the end result. So it actually comes out with, you can see here that we're in a web browser, and you're able to see both a spider plot in this case, we're displaying the sensitivity of the gold recovered, but we can look at the sensitivity of the NPV to all the different inputs. And it also has a chart showing what's the relative impact. And then we have simulation analysis. And with the simulation, instead of specifying and varying only one thing at a time, we're able to have it run a number of Monte Carlo simulations. And it will actually, we're able to specify distributions for the variables that we want to consider. And then each run will have different settings that fit that are within the distributions that we expect. And the end result of this is that we'll have a number of likely scenarios, and we'll be able to get a report on what's the expected outcomes, rather than just getting one ultimate pit and we take that as gospel. We're able to get a good feeling for what we can expect. Also, something that we've added in SOPP is we're able to do correlation. So any variables that follow a normal distribution, we're able to add correlation between them, which would be useful in anything like gold and silver or gold and copper, which historically have a relationship. And then with the simulation, once we've run our simulation, we're actually able to find what cutoffs we have 95% probability, 50% probability of getting. So here it's saying that we will, with the mine site, there's a 90% probability that will achieve greater than 20 million grams. If we look at 50%, there's a 50% probability that will get greater than 22 million grams. So we can see actually here that the recovery is in a fairly small range. Now it's looking at the NPV. The NPV has a fairly large spread. All right. So with the simulations, we're able to specify the number of simulations. I think right now the software is limited to 2,000. That should be more than acceptable. But yes, if we find that at 50 simulations it's not enough, we can add another 50 simulations. If that's not enough, we can add another 50 simulations. And the software will just deal with that. All right. So next we're moving on to the demo. So here I'll first go. So here we are in Summit. So here I have I'm on my workspace. I can see what projects I have available to me. I have a copper project here. So if I click on that project, it will show me my different scenarios that I have run and tell me the status. So here's my completed scenario. So this scenario, we can see that I've done my model definition. The check mark indicates that the work has been done. I've completed my economic model. I've run my ultimate pits and my ultimate pit. And I've also completed a sensitivity analysis and a simulation. So just coming into the setups to see what they look like. So this scenario is currently locked, but I can come in and edit the scenario. And here it's telling me a bit about my settings. And I'm able to come in and edit my settings. So here this is the part of the model import. So it's showing my mapping, what fields have come in from my block model, and how I'm using them in the process. So I've got a rock code. I'm using that for my rock types. Once I've got that set up, I can actually specify my rock types. And if I had another one that was a slope region, I would be able to use the codes in there for my slope regions. So that is the model setup. Lots of this will be familiar to users who are familiar with NPV Scheduler. The main difference is that here all the settings are on one panel. So here with the economic model, we're able to set up our product revenue. So here we're bringing in gold at $12 per gram, and we have an associated selling cost or marketing cost, and also our copper. We've set up our mining costs at $1 per ton because the block model actually has a cost adjustment factor built into the blocks. We can set up what different processing methods we have. So we've got the mill and the leach. We can have cost adjustments by bench. Also, we are able to set up formula variables. So down here we have an example of a recovery that's being calculated based on a formula. And those formulas are actually able to use the formula variables. So you might have a variable that you use here, a recovery variable that's used in by multiple processes. And you'll actually be able to check the sensitivity to that variable at a later time, or, well, through the simulation. So, close that. So then we've got our economic model, our ultimate pit. We're able to set up our discounting and mining rate per year. We are able to either use the initial topography, which is the top of the block model, or we're able to bring in a surface, and that surface would define, or it might be a currently mined out topography. Here's where we specify our profit factors. And yes, we can bring in strings for our pit limits. Here we've got some exclusion zones, a national park and a valley, and we also have a lake with a cost of $2 million, or capital cost of $2 million if we need to move it. And we're also able to set up our slope regions. So that's our engineering type settings. So once we close that, it will run, and it will find us an ultimate pit. Alright, so that's all pretty normal. So the next step is where it gets interesting, where we add our sensitivity. So with the sensitivity, here on the left-hand side, we have a list of all of our variables that are available. So I can select a variable. Right now I have unit cost. I'm varying that. I'm varying the gold price, the copper price, the mill processing costs, and also the slope angle. But if I wanted to change another recovery, I can come in here, hit the button, and now that's there, and I can edit that. And I can either give it a list, or I can give it I specify a center and a number of steps in either direction, and an increment, and it will just create the cases. Close that. One of the things that the software does is it remembers which cases have been run and which cases haven't. So every time you change something, you don't need to rerun everything. You'll just rerun that case itself. So I'll open up a sensitivity case here. So as an example, we've got our sensitivity. Now I'm going to look at the reports for that. So first I can check my sensitivity results. It takes a bit of time to come up. So that's just, it's a table showing me what the results of all my different runs are. My new ultimate pit. I can export that. I can also look at my reports. So here, overall impact on KPIs. So here's the variables. Nothing is affecting capital cost. I can choose something else for that chart to show. Recovered gold. So recovered gold is mostly affected by the gold price and the slope angle. Our mining costs are mostly affected by AU price and unit cost. The ore mass is more based on the copper recovery. So you're actually able to customize these reports to see what you want to see. Then if I move here, I can see the same thing but in terms of spider plots. So that gives us a bit more detail about what the shape of the curve or relationship is. And then if we want to, we can actually come into a detail view and look at one particular thing. So we want to see what's the biggest effect on the NPV. And so of all the cases that we've run, that's the shape of, that's the relationship to the gold price. This is the relationship to the copper recovery. And so yeah, it's convenient, it's fast, and you're able to look at a lot of different things or a lot of different outcomes as far as your KPIs. So next, we'll go back to our settings for our simulation. Sometimes it takes a bit to load up. So in this case, we've got a simulation. We're running 150 iterations, and we are looking specifically as an input the gold price, the copper price, and the processing cost. So in this case, the gold price and the copper price are normal distributions. So we're able to specify the mean, standard deviation, and also give it some maximums and minimums to keep things within reason. Copper price, we can do the same thing. I'll not change that setting. The oxide mill processing cost, we've actually gave it a triangular distribution. So the most likely value will be 12. The minimum will be 6, and the maximum will be 16. And here we've specified the correlations between those two cases. So there's a strong correlation. And then we're able to come back here, close that, and go to our reports. So here it's just going to list what our results are. It may take a second to pop up. Oh no. All right. So that's unfortunate. All right, we'll see how quickly that comes back up. No. All right, here. So my cases have come back up. I haven't lost anything. So I can check my simulation. Oh, I've just switched to a different case. So this simulation is varying. In this simulation, we're varying recovery, copper price, gold price, mining unit cost, and some other recoveries. And the results, the reports for that, are coming up. So here we can look at different parameters and see, so the parameters we're looking at actually what the distribution is of the cases of what parameters were generated. So our gold price, all right, that's the shape of the distribution. Maybe I'd want to run some more cases because here at the 13, that seems to be underrepresented, but it is random, so it can be. And then we can also, so this is looking at the parameters, but we're also able to look at the KPIs. So the capital cost isn't varying in any means by the cases. But our NPV, we're seeing that yes, our NPV, the most likely option is right between 90 million and 110 million. We do have some fantastic cases where it reaches up to 220, but you would expect to get a result somewhere between, say, 70 and 160 million. Right. Now we can also just come here and look at the simulation data. And this is where we're actually able to calculate our 95% cutoff. So that's just listing the results for all the different cases. And here's our statistics. Okay, first, so let's look at the sensitivity NPV. So there's a 90 of the scenarios, 90% of the scenarios were greater than 62 million. I can say, all right, what 60% down here. 60% of the cases will be greater than 80 million, and we can look at different things here. All right, so that is Summit as it is. So now I'll go back to answer any of your questions. All right. So the first question we have, it says, how does it create pushbacks if it doesn't follow the LG nested bit? All right, so this is a question more about NPV Scheduler. So NPV Scheduler, when it's creating the pushbacks, is actually looking at it's using the optimum extraction sequence number. So there's the block that needs to be extracted first, and then so it will take that block and it will start gathering the blocks near to those blocks with low optimum extraction numbers. And then once it reaches the required tonnage, it will check and see if there's any blocks around that are kind of orphans, and it will gather those up. Also, as it considers working area or mining width and different things like that. All right, we have a question here also. Can you guarantee the security of the data on the cloud? The data on the cloud is on the Microsoft Azure cloud platform. So it is secure to government standard. All right, this is secure to military standards. I think we have the example Lockheed Martin, which is a military defense contractor, and lots of different companies are using the Microsoft Cloud for their data, which means that these companies that deal with top secret things are willing to use that data or keep that data on the cloud, and they believe that the security enough? All right. A question here, for simulation, can we have different distribution types, for example, log normal? So the current distribution types that we have are, so there's the normal distribution, there is the triangular distribution. We also have, we can have a distribution where basically it's a set of bins where you have a series of values or steps and each value is as likely. Or you can have a distribution that's like a random range. So so you specify a minimum and a maximum, and any value within that range has the same likelihood of occurring. I think as far as log normal, if that's expected, it shouldn't be hard to, well, we can talk to the developers and get that in. All right. A question here. So what is the cost? All right. So Summit currently is not available, but it is scheduled to be released in January. So I think we do have a licensing model or a cost model for that, but it's probably more best if you contact us and we'll talk to you about the needs. All right, but Summit is currently available for us to do consulting work on it, and also if any parties are interested in doing pilot projects, we're definitely happy to have test data to work through. All right. If I want to review the pit shapes generated, what tools are available? So I wasn't able to show you today what's available, but right now, so they're working on it, that we'll be able to actually view the shapes. If you do have a scenario and you also have NPV Scheduler, you could use the same input settings and it would generate the pit shell. You just wouldn't have to run all the different sensitivities and simulations to get that. But that is slated to be brought online. All right, I have another question. What about poor connections on site? So right now, if you're on site and you have poor internet connections, we still do, we have NPV Scheduler. We have it for the foreseeable future. But SOPP on Summit, the plan is that we will have a standalone version of it. So at that point, you won't be able to harness the power of the cloud, but you should be able to, once you've lost the connection to the cloud, well, you can still use the cores on your own machine and use that locally. So at that point, you should still have the same reporting, same ability to do the reporting and run the multiple scenarios and simulations. You just won't have all the power on demand that you have on the cloud. Another question. Is there a problem with transferring huge files like block models to the cloud? And with this one, the system actually is able to accept zipped files. So yeah, with lots of block models, you might have a multi-gigabyte block model, but when it's zipped, at least with the data mine format files, those usually compress to around 10% or 5% of the original size. So, you know, it's a much less data to transfer. So definitely we can transfer everything zipped. Right. Back to Eloise.
Okay. So we've just about run out of time, so this marks the end of our webinar. Thank you all for attending, and we hope you found the content presented valuable. If you submitted a question that we were unable to address, please rest assured that we have recorded these and we'll get in touch with you as soon as possible. Once our webinar has wrapped up today, you will be redirected to an online feedback form. It will take no more than a few minutes to complete, so if you have the chance, we'd really appreciate your thoughts on how today's webinar went. We will be sending out a follow-up email to all of our attendees. This email will provide you with a recording of the webinar, as well as the necessary details to contact us should you have any additional questions. We look forward to hearing from you soon. Thank you all once again for attending CAE Mining Strategic Open Pit Planning Webinar. And thanks again, Lee.
All right. Thanks.
Thank you. Please stand by.